The James Webb Space Telescope has uncovered more than 700 previously unknown galaxies. What initially seemed like a groundbreaking success quickly transformed into a deep cosmic mystery. Among the countless star clusters, scientists observed structures that starkly defy our current cosmological models, galaxies that, by all logic, shouldn't exist. These so-called impossible galaxies are shaking the very foundation of our understanding of the universe. So what does this mean for the bigger picture? Are we on the verge of abandoning the long-standing standard model of cosmology? And if the universe didn't begin with the Big Bang, then how did it come into existence? Join us as we explore these mind-bending questions and dive deep into the unknown frontiers of space. On December 25, 2021, a historic moment unfolded. The James Webb Space Telescope launched into the cosmos, carrying with it the hopes and dreams of scientists around the world. Built specifically for infrared astronomy, Webb's mission is nothing short of revolutionary: to transform our understanding of the universe by literally peering back in time with the most powerful space telescope ever created. One of the James Webb Space Telescope's primary scientific missions is to explore the first luminous objects and galaxies that emerged after the Big Bang, during what's known as the Dark Age, about 13.5 billion years ago. In 2023, Webb proved its incredible potential by advancing our understanding of early cosmic evolution to unprecedented levels. After its initial images stunned the world, Webb, through the JWST Advanced Deep Extragalactic Survey, JADEs, identified an astonishing 717 early galaxies that had previously been completely hidden from our view. These ancient structures date back to just 500 to 850 million years after the Big Bang, and scientists hope they will help refine current cosmological models. However, the universe often defies expectations, rewriting what we think we know. To grasp the significance of these findings, we need to revisit what researchers initially anticipated from this era. The prevailing scientific view holds that the first stars appeared roughly 200 to 300 million years after the Big Bang, and the earliest galaxies were expected to be tiny, mere dwarfs compared to those we see today. And based on the laws of physics, that assumption made perfect sense. According to our current models, there simply wasn't enough ordinary matter in the early universe to form galaxies as massive as the Milky Way. But as it turns out, the cosmos doesn't seem particularly concerned with our theoretical limits. The James Webb Space Telescope has revealed something in the far reaches of space that, by all accounts, shouldn't exist, and it's been baffling scientists ever since. This is the discovery of the seemingly impossible. Astrophysicist Ivo Labbe and his team at Swinburne University of Technology in Melbourne were analyzing data from the James Webb Telescope's early release observations, specifically images captured by the NIRCam, near-infrared camera. These images focused on a patch of sky near the Big Dipper, a region considered part of the cosmic dawn, the era when the first galaxies began to form. It didn't take long for Labbe and his team to realize they had found something extraordinary. Describing the moment, Labbe said, "I ran the analysis software and it spit out two numbers: distance, 13.1 billion light-years, mass, 100 billion stars. I nearly spit out my coffee. I knew we had just uncovered something impossible, galaxies that were both incredibly early and impossibly massive." And there's a reason Labbe emphasized the word impossible. For galaxies of such size to exist so early in the universe, the matter density back then would have needed to be 2 to 5 times higher than current models predict. Either that, or galaxies formed through a process that we still don't understand. Regardless of the perspective, scientists hit a cosmic roadblock. Both scenarios demand a major shift in how we understand the evolution of the universe. So far, no clear explanation has emerged for this astonishing discovery. What we do know is that just 500 to 700 million years after the Big Bang, there were already 6 galaxies with masses of 10 billion, and in one case, even 100 billion, times that of our Sun. Essentially, galaxies that should have been in their infancy had already grown to the size of today's Milky Way. This revelation from the James Webb Space Telescope contradicted nearly every established model of cosmology, earning these mysterious structures the nickname universe breakers. And as it turns out, this was just the first in a long line of equally baffling discoveries. The galaxy known as JWST, discovered not long ago, existed just 290 million years after the universe's birth, yet it already appears far too large and filled with stars for its young age. Only weeks before that, the James Webb Space Telescope identified Sears 2112, a surprising twin of the Milky Way. This galaxy had already developed a central bar structure 11.1 billion years ago and was 10 times more massive than our Milky Way is today. These early cosmic anomalies are putting serious pressure on our current standard model of cosmology. In fact, some scientists are using these seemingly impossible structures to support a highly controversial idea, that the universe may not have formed the way we've always believed. In other words, the Big Bang Theory could be wrong. But what's behind this bold claim? The Big Bang Theory, in simple terms, describes the simultaneous creation of matter, space, and time from an initial singularity. So how can we study the origin of everything, some 13.8 billion years after it happened? It's possible because the universe has been expanding ever since. However, it's important to note that the cosmos isn't expanding into an already existing space. Instead, space itself is continuously stretching outward. If we trace this cosmic evolution backward, we can calculate our way to its origin. Eventually, we arrive at a moment where matter and energy reach infinite density, and all spatial distances shrink to zero. One of the strongest pieces of evidence supporting the Big Bang Theory is the discovery of cosmic microwave background radiation, nearly uniform radiation that emerged about 380,000 years after the Big Bang and still permeates the universe today. However, it's important to clarify that current models and theories don't describe the Big Bang itself, but rather the moments immediately following it. Specifically, they focus on the period between one Planck time after the event up to about 400,000 years later. What exactly occurred during that elusive Planck time, the smallest measurable unit of time according to known physics, remains a complete mystery. And while the Big Bang Theory is widely accepted by scientists, it's not without its critics. One major limitation is that it doesn't explain how or why the universe came into being in the first place. What sparked the sudden emergence of something from nothing 13.8 billion years ago? Is it even possible for anything to form out of true nothingness? Was the birth of the universe triggered by a specific cause, or was it purely coincidental? While the Big Bang Theory remains the prevailing explanation, several intriguing alternatives have emerged. One of them is cosmic inflation, a mysterious phase in which the universe is believed to have expanded exponentially within a fraction of a second. But not all scientists agree that this event ever occurred. Russian cosmologist Andrei Linda, however, holds a different view. In the 1980s, he proposed that inflation is not a one-time event, but an ongoing process that only stops in certain isolated regions, forming what he described as bubble-like subareas. These bubbles could each represent individual subuniverses, each governed by its own values for the fundamental constants of nature, and therefore its own unique physical laws. If this theory holds true, then our universe is not the entirety of existence, but just one small piece in an endless multiverse, an infinite chain of universes, each distinct from the next. Another fascinating theory suggests that our universe isn't a one-time occurrence at all. Instead, it may have been created and destroyed countless times in an ongoing cycle. Some physicists believe what we call the Big Bang might actually have been the result of a big crunch, the collapse of a previous universe. According to this model, in the far future, gravity could eventually overpower dark energy. If that happens, the universe's expansion would reverse and accelerate into a contraction, ultimately collapsing in on itself once more. In the final stage of this cosmic contraction, a single colossal black hole will remain, containing all the matter in existence, only to eventually consume itself. Yet, it's possible that this very entity could become the seed of a new universe, beginning the cycle anew and continuing it for eternity. Physicist Nikodem Paplowski from the University of New Haven shares a similar perspective. He proposes that our entire universe may exist within a black hole. According to this theory, a kind of primordial core once formed at the center of one of these massive entities, eventually rupturing and giving rise to the cosmos as we know it.